Okay, for this next question, again, I would like you to grab your graphing calculator and we're going to enter into our y equals negative 4t squared plus 48t plus 3. And there's a sketch the graph of the function. Now before we do that, I guess let's just read. It says the height above ground, h, in meters of a projectile at any time t in seconds after a launch is defined by the function h of t. So a projectile is something like a rocket, right? It's projected. It's shot in the air. It could be, a bullet could be projected, right? A projectile, something that's flying quickly through the air. So the height is our y-axis. So I'm going to put h, height in meters, and of course our time in seconds goes along our x-axis. Okay, now notice we're just mostly concerned with our first quadrant here, and we want to sketch the graph and state the window settings. So when I've already entered that equation into my calculator, so if you haven't done so, then pause the video and do that. But we've got our y equals negative 4x squared plus 48x plus 3. And as soon as I push graph, I see what looks almost like a linear function, even though I know that it should be a quadratic function in the shape of a parabola. So what I want to do is have my calculator help me. So what I'm going to do is I'm going to go to zoom fit. Okay, and what zoom fit will do is it allows my calculator to sort of see more of the graph, including the vertex. I know I mostly am concerned with quadrant 1, so I'm going to go into my windows that my calculator set for me when I did zoom fit, and I'm going to adjust them accordingly. Because right now, I don't need to see all the negative time, nor do I need to see all the negative height. So for my minimum x, I'm going to change that to, instead of negative 10, maybe like negative 1, just to see a little smidge. Whoops. Negative 1. And then our minimum y. Now TI-83 does not have these auto features, but I would change this to like maybe a negative 1 or a negative 10. And there I can see almost everything. I can see that I need to move my graph over a little bit to the right. So I'm going to go into my window that was preset when my graphing calculator did a zoom fit. Right now it's at a 10. I might change that to a 20 or maybe a 15. If I do a 15 and it didn't fit, I would just move it over further. And then of course my maximum window here, it's on auto, but I can see that it's just beneath 150, so I might change that to 150 for those of you who have the TI-83. Okay, it's right near the top there. So my calculator, I've made it look, I can see the first quadrant. I want to look at my window and be able to identify those. I've got a negative 1, 15, and a negative 1 and 150. So I would write those down. My x would be negative 1, 15, and a 1 scale, and my y would be negative 1, 150, and a y scale. I left my y scale as 1. We could change that to a 10 or something like that if we wanted as well. Now the first question, and of course let's just do a little mini sketch here. I know that my y-intercept does not go right through the 0, 0, because of course my y-intercept is 0, 3. So one of the first things I would do when I'm doing a question like this is I would find my y-intercept, which I know right away is 0, 3. I would find my vertex, and I would find my x-intercept. So why don't we go ahead and do those and identify those on the graph quickly. So when I go and want to find my max, I've got a left boundary. I can stop any time. We've got a right boundary as soon as I've moved to the right, and right away that is 6 and 147. So I will label that as 6 and 147. And then I want to find my x-intercepts, which we call zeros of the function. The x-intercepts of the graph are the zeros of the function, which are the roots of the equation. Now in this case, left is above the x-axis, so I can see that my y values as I scroll are still positive. I'm going to push enter, And then I'm going to need to scroll so that my y values are negative. It's difficult to see, so I could have even changed my window to maybe a minimum y of negative 10 or something like that. Then I can see my x-axis a little bit better. So let's do that one more time. There's our 0, my left boundary, my right boundary where it crosses, and it tells me that my 0 is 12.06, and of course y is 0. Right, on my x-axis, my 0 is 12.06 and 0. So let's just identify that. That's what that point is. Let's just scooch that into the left here. Now, usually this is enough to answer all of the next questions. The first question says determine the height of the projectile 3 seconds after the launch. Well, in this case, I actually can't answer with these 3 points, but if I know the projectile is 3 seconds, what is 3 seconds? Well, 3 seconds is time. So I know that x is 3. Okay? Algebraically, I could always throw a 3 in for t and solve that for the height. Or if I'm using my calculator, I know that I can use the function to calculate the value when x is 3. Okay? I went to second function, calculate number 1, the value when x is 3. And y would be 111. So second calc number 1, the value when x is 3, and our y was 111. So therefore, that's 111 meters. Because keep in mind, as you all know, that every single point on this graph has the interpretation of the x value being time. So in this case, this is 0 seconds and 3 meters. This is 6 seconds and 147 meters, and 12.06 seconds and 0 meters. So the question was the maximum height reached by the projectile. We can easily see that that's 147 meters. After how many seconds did the projectile reach the maximum height? After 6 seconds. Okay, what was the initial height of the projectile at the launch? Of course, at time 0. Okay, at time 0, the height was 3 meters. Okay, so maybe it was something launched off a rock or something like that. Okay, at what time did the projectile reach a height of 100 meters? To do this kind of question, when it reached a height of 100, here, in fact, we know that y is 100. Our height, right? Our height is 100. So what I'm going to do is I'm going to put a second equation into my calculator. Y is 100. And when we graph that, we now have 2 points where the projectile has a height of 100. How do we find those intersection points? To find the time, we choose number 5, intersect. There's our left boundary and our right boundary. And our first point there, when the height is 100, is 2.57 or 2.6 seconds. Okay, so what that looked like here, this was 2.6 and 100. Okay, so we're looking for 2 answers here, aren't we? Because, of course, time was 2.6 seconds. Okay, and we have a second point over here. After the projectile reaches its maximum height, it comes down. So our second point would be, just scroll over. Again, we need a left boundary and a right boundary. And keep in mind, this is a little bit different than the TI-83. There's our value there, 9.42 or 9.4. So that's the second time, which would be 9.4. And then finally it asks to state the domain and range for this function. So our time, which is our x, right? X is time. And range, our y is height. So we could use, in fact, h and t, or I'm fine if you just continue along to use x. So I know that the smallest x value, my smallest time is 0, and our largest time would be 12.1. Round to the nearest tenth if necessary. So remember, rounding counts. If you don't round properly, you're going to lose a half a mark. So 12.06 to the nearest tenth, that's 1 decimal place, right? There's our 10th spot. So we're going to round up to 12.1. So my smallest time is 0. Our largest time is 12.6. 12.1 rather, 12.06, which rounds to 12.1. And we can put our XCR. Okay, if you use T, that would be fine as well. And for our Y, our smallest Y value is 0. And our largest height there was 147 meters. Okay, so if you were to practice this question, we've already done number 1. I would say for sure you should practice and try number 3 at a minimum. Okay, good luck, and if you have any questions or concerns, please do not hesitate to contact me. Thank you.